So 4.4. It's going to be cut into 2 videos. Maybe when I upload it to YouTube, maybe it's going to be one whole video, so you fast forward to the section that you need. So basically, this is the deal. There's about 10 examples, and each example has an AB, maybe A, B, C, D. So it is a long lesson. First problem, I'm having to solve, remember, your whole goal throughout this whole lesson is to solve for x. So x is an exponent, so I need to figure out how do I move it to the bottom. When there's no e, when there's no ln to start off with, you have to try to get the same base. Base means this number. So 2 to that power equals 2 to what power gives you 16? 4. So 3x minus 8 equals 2 to the 4th. Because 2 to the 4th is 16. Are we okay with that? Yes? This number and this number are the same. Once those numbers are the same, we could ignore them and bring your exponents down. So 3x minus 8 equals to, just kidding, not 16, but what? 4. Sorry. Equals to 4. Now, what do I do to solve for x? Add 8, 3x equals to 12, and then divide by 3, so x equals 4. Was that bad? No. Part B. Let's say I have 27x plus 3 equals 9x minus 1. So here I have 27 and 9, and I have to think of a base that I could get 9 and 27 from using what number? 3. 3 to what power gives me 27? 3 to the 3rd power is correct. Now please don't forget, I already have an exponent, so that has to stay up there. And 3 to what power gives me 9? 2. 3 to the 2nd. So this is x minus 1. Are we okay there? Yes? So, x, are your bases the same?
Yes.
We ignore them, bring down your exponents. And when I bring down my exponents, because there is a parenthesis and there's a leading number, I have to use what property? Distributive. So this becomes 3x plus 9 equals 2x minus 2. And then we solve for x. And with that, you guys should be okay and comfortable. Yes? So I subtract 2x, subtract 2x. X plus 1 equals to a negative 2. Subtract 9, x equals negative 11. How do we feel about that? Easy? Good. I'm glad. So, can I move on to example 2?
Yes.
The title is the same thing for all the examples. It's just different situations. For instance, we're going to look at this problem. 4 to the x power equals to 15. Now, the question here is, can 4 and 15 come from the same base? No. So in problems like this where you cannot get the same base, we're going to have to use something else. In this case, we're going to have to use ln on both sides. So always remember mathematics, what you do to one side, you have to do to the other. So, we've talked about properties, we've talked about rules. What do you think we have to do here? Can I use the product, quotient, or power rule?
Power.
The power. And what does the power rule say? If you have an exponent, it goes to the front. So this guy has to come up here. So this becomes x ln of 4 equals to what? Alrighty, so then this becomes, we said it was going to still be ln of 15. Now remember, your goal here is to solve for x all the time. So is x by itself?
No.
Who's next to it that I need to get rid of?
ln.
So how can I get rid of ln of 4 here?
Subtract.
Not subtracting. Is there a plus?
Divide.
It's understood to multiplication, so I have to divide. It's understood to be multiplication, so I have to divide. So my answer is ln of 15 divided by ln of 4. Now, your answer may be like this, or it might be in decimal form. Depending on what your answer choices look like, that's what you're going to have to do. So, let's go ahead and plug it into the calculator. So, control divide, ln of 15 divided by ln of 4. And we're going to round 3 decimal places. We press enter, 1.953. 1.953. So, how do you know, Miss, if I'm going to just stop here or go there? Look at your answer choices. Do they go all the way to a decimal, or does it stop right before? Now, the next problem. 10 to the x equals 120,000. Another way that we could solve for this, not the ln, but we could use logs. Now, here goes my question. If I want to get rid of the 10, what does my base have to be? 10. So we have learned that if I put log base 10, and I'm putting the 10 to the x, equals log base 10, 120,000. Whatever you do to one side, you do to the other. Why did I use a 10? Because this is a 10. If it would have been a 3, I would put log 3, log base 3. Now, we've talked about this. What happens when you have that?
The 10 cancel out.
It cancels, and the only thing that you have left over is x equals log base 10 of 120,000. Now, let's put that into the calculator. That would be it. You've already solved for x. So, we grab our calculator. Control log. Do I have to put the 10? Not necessarily, because it knows it's that, 120,000. We press enter, 5.079. So your answer could either be in logarithmic form or in decimal form, depending on what your answer choices look like. Easy? Yes? So I want you to try one of each right now. So review, problem 1. Questions? No? So question 1 would be this. 3x plus 1 equals 1 over 32. So it looks a little bit different, but let's see.
So you only do log if it's a 10?
No. You could, and I'll show you right now. You could use it in other times too. So let's look at these two. How do you get a fraction as a number? What does your exponent have to be? Not a fraction. Can I get a 32 with the base 2? 2 to the what power?
Negative.
It's just 2 to the what? 3. But if I want to move it to the bottom, my exponent has to be what? Negative. So this here becomes 2 to the negative 5th. And then do the front part. I'm going to pause it, work on it, and then I'll show you the answer. Now, those of you who are having to see the video, please understand you can pause this as many times as you want to help you. And in case you guys need to see it again, please stay tuned to the next commercial. Yeah. What should we advertise?
Water.
Water? Anyhow. 3x plus 4. So work it out all the way until you figure out what x is. Could your answers be negative? Yes. In about 5 seconds, I will show you the answer. If you're done, you check. If not, you're supposed to keep working on it. Ralph, you already have the answer?
Yes.
Is this what you got?
Yes.
Perfect. Did you work on number 2?
No.
Okay, let's start working on number 2. If you've already done 1 and you don't have any questions, please let me know. If you do, please let me know. Now, number 2 is like an example. Number 2, part A. So this is my answer. Please check it. Once again, you don't need a calculator until the very end. But sometimes you're not even going to have to go this far, but I need for you to know how to plug it into the calculator. Now, why did I copy the problem again in the bottom? Because right now, Ralph had the question of, can we only use log when it's a 10? No, you can use the log when it's a 5, when it's a 3, when it's a 4, when it's any number. So here, because this is a 5, what base am I supposed to be using?
5.
So I'm going to put log base 5, 5 to the x equals log base 5, 134. Now, what happens with the log base 5, 5? So I get x equals log base 5 of 134. So I'm going to plug this into the calculator.
Now it seems good.
It seems quicker, but this is the only time. Let me tell you something. Did it give me the same answer?
Yes.
Yes. Now, yes, it does seem quicker. The only problem is this. You could only use log when your exponent is an x or 2x. If we're adding or subtracting something to it, you have to use ln.
So if it's an x or a 2x?
X or 2x or 3x. Like if it's just an x, like being multiplied times a number, like 1/2 x, you could use it. But if we have 3x plus 5, 3x minus 2, because there's more than one thing up there, you cannot use log.
What if it's a negative?
You can still use it. Okay, so are we good? Yes?
Yes.
All right. So this page gets you through problems 1 through 4. 1 through 4 on your assignment of 16. Turn the page. Example number 3. Solve an exponential equation. Again, same thing. This one's going to look different, so it just depends on what you get, what we could do. So it looks completely different, but we should still be able to work on this. So 40e to the exponent of 0.6 x minus 3 equals 237. So what do you think is the first thing that I could do here? Add 3, get rid of the 3. So we get rid of the 3 by adding 3. Perfect. So I add 3, 40 e to the 0.6x equals 240. What's the next thing I could get rid of?
Can you put the 0.6 to the front?
Not yet. Divide by 40. We have to get rid of the 40 first. Get rid of the 40. And we divide because it's being multiplied. So equals to what?
60.
It's just 6.
Oh.
It's just 6. Now, our goal here is to solve for x. So we need to bring that x down to kind of be like a big number. But we have learned that the only thing that gets rid of e's are ln's. So I have to put an ln in front of this and an ln in front of that. Yes? So ln and e, what happens? Crosses out. This is just 0.6x. So we're getting closer to solving the answer. Can we eliminate anything here? It stays ln of 6. Stays ln of 6. But remember, your goal is to solve for x. So who do I still have to get rid of?
0.6.
How do I get rid of 0.6? Divide. Very good. It's division because it is multiplication. So x equals ln 6 divided by 0.6. And we put that into the calculator really quick before we stop. We can finish this. Control divide. ln of 6 divided by, whoops, that goes in the bottom. Gee, well, that's 0.6. What is it?
2.986.
And so that's 2.986. All right. Are we good? Okie dokie. Please try this one on your own. 7e.
Whoa.
Sorry, there it is. So it's the same type of problem. The one on your assignment is actually easier than this, but if you understand this, you're going to be just fine. You will survive. So start doing the steps. I'm going to pause this. Do a step or two, unpause. If you want to be checking your work as you go, I've been pausing, unpausing, and everything. This is my final answer. Yes? So, looks hard, looks confusing, but it's basically the same rules you've been talking all through Algebra 1. This is Algebra 2, but it goes back to your basics. You're adding, you have to move it over, you subtract. You're being multiplied, you divide. The only thing that we're adding is these little last steps where we have to get rid of the e, so we have to do the ln and stuff like that. Questions? Are we okay? Yes? All right. Example number 4. These are the ones that are kind of long. Yes. Solving an exponential equation. Okay. Two x plus 3. 2x plus 3. So I might have to draw a little line. If not, I will start writing really big. So my question here is, can I use log?
Yes.
No, because I have more than one thing. So can I get the same base? No. So I have to use what? ln. So I'm going to have ln of 5, ln of 4 to the power 2x plus 3. So this is where the question, next question would be, What did we say we had to do in the first problem in example 2? Move who to the front? So we have to move these little exponents to the front. So this becomes x minus 2 ln of 5 equals 2x plus 3 ln of 4. Now here goes a quick question. And a regular problem,
We write that down, do
you don't have to write this down. When you have a problem like this, what do you have to do?
Distribute.
Distribute. Now, it just looks weird because it's in the back, but it's the same thing as having this. Do we agree?
Yes.
Yes? Guess what you have to do in this problem?
Distribute.
Who do we distribute here?
Five.
ln 5. So this becomes x ln 5 minus
ln 2.
2
ln
ln 5 equals
2x ln
2lx and 4 plus.
3 ln 4.
So this problem just got crazy and it got long. And it's not going to get pretty until the very end. Now, when we solve for a variable, they usually tell us move all your x's to one side and all your numbers without variables to the other side. Yes? So, who do you think we have to move?
The 2x ln 4.
The 2x ln 4 to the other side. How do we move it?
Subtract it.
So I'm going to subtract 2x ln 4 and subtract 2x ln 4 from both sides, because what you do to one, you do to the other. Now here they cancel. That was the whole purpose, to get rid of it. Now, can I combine my x's? No. Because one is ln 5 and the other one is? So I'm just going to write these down. Does it matter what order we write them in? No. Honestly, it doesn't. So, the 2 ln 5 comes down, 3 ln 4 is right there. So now who do I have to move over to the other side? Plus 2 ln 5 plus 2 ln 5 crosses out, x ln 5 minus 2x ln 4 equals 3 ln 4 plus 2 ln 5. So, what do you think we have to do next? Any ideas? Can we?
No.
What if I gave you a problem like this? What can I do? Factor out x, right? So this, we factor out an x, and this becomes 1 minus 2. Do we agree? Yes? Okay. So we could do that here. We're going to factor out an x from here. And when I factor out an x from there, what do I have left over? ln 5. When I factor out an x from this part, what do I have left over?
It's negative 2 ln 4.
ln 4. 3 ln 4 plus 2 ln 5. Ugh, almost didn't fit. Who are we solving for?
X.
Have I done that yet?
No.
There's one last thing you have to do, which is divide.
Oh my
X
God.
is being multiplied by that, so now we divide everything by ln 5 minus 2 ln 4. Divide by ln 5 minus 2 ln 4. So x equals that, and I'm just going to rewrite it just for courtesy. ln 5. And then we have to put it into the calculator and figure out what that right there is. So your answer could stay like this, or they could actually make you get a whole decimal to it. So control divide, 3 ln of 4. Make sure you move out of the parentheses, because In my other class, I had a student who's like, Miss, that's not what I got. Because he just kept typing like crazy. So 2ln4 plus, yes, ln5 minus 2ln4. Please practice the typing in, even though some of you think, oh, this is a piece of cake, kindergarten could do this. Sometimes you make careless mistakes. You press enter, and this is my answer. X equals negative 6.343. Questions. So is it a lot of work? Yes. Do you think you could do that on your own?
Yes.
I think you can. You're like the little engine that could.
No, I couldn't.
Or that couldn't. Are you little Thomas or not? So I want you to try this one on your own. So here's a problem you have to try on your own. I'm going to pause this. I'm going to work on it completely and show you the answer until the very end. So work on it, follow the same steps. Sometimes the question is, do we have to put the ones? It's up to you. It's your choice. I've done up to that part. If you want to check your work, make sure you plug it into the calculator and get the decimal form. Once again, if you don't have a calculator, you can work it out all the way until that part. Once you are done, look up here. Now, I want you to understand something. If you got through all that, or if you got through most of that, do you feel like, damn, I'm awesome?
Yeah.
And this is why, you should feel accomplished that you could do all that. I don't think I could do all that by the time I was a sophomore or a junior in high school, honestly. So you being able to do this, it's like, whoa. And it all goes back to basic algebra skills. So now they're just throwing in some extra weird stuff in there because they have nothing better to do. So, questions, concerns, doubts, clarifications.
What, like, numbers is this gonna help us for?
This here, very good question. This should help you for 5 and 7.
That's it?
Yes. And example number 3 was for number 6, which I didn't tell you. So 6 for 3, 5 and 7 from 4. Can we move on? Yes? Crazy? The one on your assignment is a little bit less complicated. But if you could do this, you should be able to do less complicated, definitely. Alright? So, example number 5. This one we change. Solve logarithmic equations. So we've been dealing with mostly exponentials. Now we're going to deal with logarithmic. So it changes the story a little bit. Log base 4 x plus 3 equals to 2. So let's say you have this problem. Log of what would help me solve for this?
4.
Log of 4, right? And then you would put log of 4 on this side also. When you have a problem like this, it works the opposite way. Whatever your base is, that's the number we're going to have to use. So in this case, my base is 4. This becomes the exponent. And it's weird, I understand. So basically, you look at your base. Base is 4. We write them down. Whatever you have becomes the exponent of those 4s. Are we okay?
Wait, why?
Because that's the only way we could get rid of log.
Okay.
So let's just say I have my calculator. And I am going to put 5 raised to the power of log. I'll put a 5 there. And just give me a crazy number.
24.
24. With what I just told you right now, this should what? Cancel. And my answer would just be 24. Is it? Yes. It's just a property. Just a way having, well, I don't even want to go into it. So anyways. So, this cancels. What do you have left over here?
X plus 3.
X plus 3. And we still have 4 to the second. What is 4 to the second? 16.
Oh.
And then how do you solve for x?
Subtract 3.
Subtract 3, subtract 3. X equals 13.
Oh my God. Well,
It's easy if you know your rules. Right, Ralph?
Yes.
Please quit. Por favor. So try this one on your own.
no.
So try that one. I'm going to pause this. Hopefully you know what number to use, right? You do? Please tell me yes.
What's
The number you use, and then your whole problem becomes the exponent. So, did you rewrite it like that? At least for now.
yes.
Questions? Are you ready for the answer? Yes? This is what I got. Do you agree?
Yes.
Yes? This is going to be for problem number 8. What do you think we have to do in a problem like this?
E.
We have to use the E. But before we use the E, we need to move some stuff first. Who can we get rid of?
The
3.
The 3. How do we get rid of that 3? Divide by 3, divide by 3. So we have ln of 2x equals to 4. Now, ln, we have to do the e. And just like the top, this becomes e to the power of ln 2x equals e to the 4th. And just so we see this, I'm just going to e ln of 24. So your e and your ln show what? And it should just be 24. And yes, that is true. So that's the whole purpose. We eliminate these guys. My answer is just 2x equals e to the 4th. E to the 4th is an answer, is an actual number. But what's the one thing I still have left?
Divide by 2.
Divide by 2. So ex equals e to the 4th divided by 2, or
27.29.
very good, e to the 4th divided by 2, 27.299. 27.299. Crazy? Not really? Let's look at this problem. And this problem is going to be like number 9. This problem is like número 9. Problem like number 9. Let's look at D. What's the first thing I should do for D?
E.
Before that,
Oh, wait. Right?
take care of what? The square root. So, ln is x plus 5. What does the square root stand for? A power of what? 1/2. What do I do with that exponent, with that power? It moves to the front. So, this becomes 1/2 ln 2 plus 5, x plus 5 is equal to 7. But now what do I have to do?
Divide by 1/2.
Divide by 1/2. What is 7 divided by 1/2? Wrong answer. Every class has been saying that.
Square root of 14.
It is 14. Now please, 7 divided by 1/2. It is 14. You guys are thinking 7 divided by 2.
Oh.
So we need to, that's why anytime that there's a fraction, I always say multiply by the reciprocal. ln of x plus 5 equals to 14. That way it's, you won't make that careless mistake. Now what do I do?
E.
E to the power of ln x plus 5 and e to the power of 14. E and ln cancel. X plus 5 equals e to the 14th, and the only thing left for me to do to solve for x is subtract 5. So x equals e to the 14th minus 5, or 1,202,599.284.
Oh, wow.
Now, fortunately, your answer is going to stay like this. Your answer is going to be something like that. Questions?
No, man.
Crazy? No crazy. Never crazy, Miss Peña.
We done?
No, never.
There's only 7 more questions.
Wait, how many questions
So, next part, example number 6.
Is this
Solving.
on
This one is okay.
the phone? Okay. I didn't think.
The only thing with these problems is we have to check our work. From here on, we have to start checking. After we finish this problem, you should be able to do 2-3 more. So we're going to look at problem A, log base 2x plus log base 2x minus 7 equals to 3. So talking about properties of log. When you see a plus, what does it mean? Multiply, right? So we cannot do anything until we reduce this to 1 log, and that's why we have to use that property. So this becomes log base 2x, x minus 7 equals to 3. Now, if it makes your life easy, you can do the multiplication there if you want to. It's up to you. It really doesn't make a difference if you do it now or later. But in order for me to solve this, I need to get rid of this log base 2. According to what we did here, how do I get rid of log base 2?
Base.
You put 2.
Base.
Make that the power of 2.
Make this the power of 2, right? So this becomes, so this is why Diego over here is saying, make it your base, make it your base. So are we okay with that? So it goes back to something we previously did. So this here, what happens? Cancels. I have x minus 7 equals 8. I should distribute here, which gives me
X squared minus 7.
x squared minus 7x equals to 8. Anytime you have an x squared, you have to move everything to one side, because we're going to have to factor a trinomial. So I would have to subtract 8, subtract 8. So this becomes x squared minus 7x minus 8 equals to 0. And then this is when you would do that, the factors of negative 8 to add up to a negative 7. Remember doing this?
Yeah.
Yes? Who has to be negative? The bigger number, because the middle number is negative. Who gives me the negative 7?
Negative 8.
So this becomes x plus 1 and x minus 8 equals to 0. X plus 1 equals to 0. X minus 8 equals to 0. You remember doing this. This is why it was very important that you learned how to factor. Right, Cody? So, this is x equals negative 1 and x equals 8. But I need to check my answers before saying those are my things.
What do you mean checking?
What do I mean check them? We have to plug them in to, you could plug them into this one or this one. I think this one would be safer. Either one, you still get the same answer, like it wouldn't matter. The only thing is, I'll tell you right now.
You have to plug in both in there?
You have to, one at a time. So, I'm going to tell you something really quick. Anytime your answer is negative, it cannot be. We cannot put negatives inside of here. So let's, and just so you see it, not so you just, Ms. Benya said so, I don't know. So I'm going to put log of a negative 1 or a negative 4, I just type it. The answer says we cannot calculate it. So anytime your answer is negative, it's not going to be part of it, but we still need to check that 8 works. So I'm going to put 2, 8 minus 7 equals to 3. What is 8 minus 7? 1. What is 8 times 1? 8. Now we learned that if we can make this number with the base of 2, and isn't this 2 to the third? Yes or yes? And what happens to these guys? They cancel. Is 3 equal to 3? Yes. So the only problem from here that's going to work, my only solution is going to be 8. And that's the way it's going to show up with those little crazy braces on your answer choice. The only answer will be 8. You're ready to try one on your own? You're like, sure, if you have no choice. Very good? Sure. So problem B, log x plus, oh, it is, you're right, it's kind of pause. x minus 3 equals to 1. So give this one a try. Same process, combine it together. Espana, there's no base. What does that mean? Oh, very good. I'm glad you remember. What is 10 to the first power? Okay. Make sure we are writing it correctly. So you're attempting, you're trying, you're doodling. Your hands aren't even on the pencil, so what are you doing? I'm just wondering. To do a correction, retraction. Stop before you check your work. We always have to check with the original problem, and I'll tell you why right now. My bad. Sometimes your answers could be negative at one point or another. So far, hopefully you have this much.
Do we have to check it?
Yes. So the two numbers that I could have, hopefully by now you know it's 5 and negative 2. Yes? Now please keep in mind, up to number 9, no checking was required. But for 10 through, I think it's 13, we do need to check. So it's about 4 problems where you do have to do the checking. So always, and this is just a correction from the previous problems, always check with the original problem. Always check with that one. So I have log 5 plus log 5 minus 3 equals to 1. What is 5 minus 3? Somebody said 2. Very good. Now, what do we have to do with multiplication? If your logs continue to be positive, you keep working. So that becomes 10 equals to 1. Is that true? Is there a base 10 here? And is there a 1 there? Does that cancel? Is that 1 equal to 1? Yes.
Wait, so we have to use the first?
The first. That's what I'm saying. Correction from the previous problem, always check with the first one. Always. Because I said if your answer is negative, it's not going to work, but it's not true. Because in your paper, a negative does work in your problem. So log negative 2 plus log negative 2 minus 3. Now, here, because it's already a log of a negative answer, it's going to be a no. Okay? Because the answer inside of the log is already negative. Right there, the answer will be a no. Right away. So, no negative inside log. So my answer is only 5. How are you feeling? Excited? Happy? Tired? I want to finish the notes with you.
What number is those for?
For sure, 10. Problem number 10. Problem number 10. I'm making notes longer with this class just because I can. Solving logarithmic equation. Alright, so it looks scary, it looks crazy, but it's not. First of all, first thing first is, it's a lot of logs. There's an equal sign, the left side, 2 logs, we need to make it into 1. And by the properties that we learned, subtraction means division. So I'm going to rewrite this as log x plus 2 divided by 4x plus 3. Are we good? Equals to log 1 over x. When you end up with a problem like this, life just got easy. Log and log on both sides. Only when you have them on both sides. The same rule applies for ln. You have ln here and ln there. You can eliminate. Only when you have made them 1. You first have to make it 1 and then work with that. So what do I have left over? X plus 2 over 4x plus 3 equals 1 over x. But I still need to solve this. But we don't have logs or anything like that anymore. The easiest way for you to do this is cross multiplication. That's the easiest way. So this becomes x plus 2 equals 1 or x plus 3. So this here becomes x squared plus 2x equals 4x plus 3. Because it has an x squared, everything needs to move where?
One side.
To one side. So I will subtract 4x, x squared minus 2x equals to 3, subtract 3, x squared minus 2x minus 3 is equal to 0. Do we agree with that?
Yes.
Yep.
Yes? So what two numbers multiplies to 3 but adds up to a negative 2?
Negative 3, 1.
So x minus 3 and x plus 1. So x minus 3 is equal to 0. X plus 1 equals to 0. X equals 3. And x equals negative 1. But I still need to check them. So, how do we check this? We plug it back where? To the original equation. So when I plug it into the original equation, I'm going to check, and it's going to be log, what's 3 plus 2?
5 over 15. Oh,
So this is 5, right? Alright, and then this over here is, sorry, I can't even think right now. Log 4 times 3 plus 3, which is what? 15 equals to log 1 over 3. Because it's 1 over x, it's 1 over 3. And then because this is a subtraction, subtraction means what? You divide. So 5 over 15. Now my question here is, what is 5 over 15 reduced to?
1/3.
1/3. Are they the same?
Yes.
Yes. So guess what? 3 is going to work. So 3 is a solution. But now we have to check who?
You don't have to.
Well, we don't have to. Just be careful. Log negative 1 right? Plus 2. So this becomes log what? A 1. So that's still a positive. So we might still have to do it. But when I put it over here, 4 times the negative 1 plus 3. What is 4 times the negative 1? Negative 4 plus 3? Oh, now because this guy's a negative 1, we don't have to do it. So that's what I'm saying. Always plug it into the original. That's where you stop. Because if that would have been a positive, you could still do your work. So the only answer here is 3. Do you need another example of this?
No.
As long as you have a log on both sides, you should be good. With this, you should be able to do 11 through 13. The last example here, we're having to do calculations, basically. I don't even know what to title it. So they're going to tell you a scenario. You invest $25,000
What?
in a bank. Whatever, I don't know. I don't think it's a bank because it grows. That means it grows to $500,000. I mean, yeah, $500,000. So it's $500,000 at a rate of 9%, and it is compounded monthly. You remember hearing these words before?
I've seen.
How many years did it take? So, when we did this in the previous lesson, they gave you the years, they gave you the money, the interest, and you had to calculate how much money. But now you're trying to see how many years did it take. Now, this was the formula that we use for the compound either monthly, weekly, yearly, semi-annually, remember? Quarterly?
Yeah.
So this is the formula we have to use. So let's plug in the information that we have. So we know P is who? 25,000. We know 1 is 1. Our rate is what?
0.09.
0.09. What is our N? 12. Now this is 12. Do we know T?
No.
That's what we're trying to solve for. Do we know how much money we ended up with? $500,000. Are we good?
Yeah.
Yes. So our goal here is with what we have learned already. How can I solve for T when it's up here?
Move it to the front.
Well, we need to eventually move it to the front, but what's the first thing, mathematical calculation that I could do here? Divide by 25,000. And what is $500,000 divided by 25,000?
20?
Yes, 20 is correct. So 20 equals 1 plus 0.09 over 12, 12t. Now, what do you think the next thing we should do is? Work inside of the parentheses. Do I have a number for everything? Can we put that in the calculator and give me a decimal, please? What is it? 20 equals 1 point something. I know it's a 1 because you're adding 1 to it. What is 0.09 divided by 12?
Oh, plus 1.
So we're putting this into the calculator.
It's 0075.
0075 to the power of 12t. Now, what can I put on both sides?
LN.
ln is correct. So I'm going to put an ln of 20 equals ln of 1.0075 12t. Then we learn, hey, if you have a power, Where do you write it?
Right.
In the front. So this is ln of 20 equals to what? 12t ln of 1.0075. Now, in order to solve for t, what should I do? Divide by what? Who are you supposed to divide by?
1 point.
The ln thing.
ln and
12.
the 12. So I have to divide by 12 ln of 1.0075, 12 ln of 1.0075. So that cancels, t equals whatever the heck this is. So they want to know how many years did it take. So when we put that into the calculator, this is what it looks like. ln of 20 divided by 12, it took 33.4 years. 33.4 years. Easy or hard?
Alright.
It's alright?
A lot of writing.
It is a lot of writing.
Yeah, I know.
So,
Like I 33.
are you ready to try one more? Just with a different formula.
This one is continuously?
Yes.
Of course.
Because you have one of each. We're still okay in time? Yes. So, let's just say you invest $1,500. We're going to make this small. At an interest.
Well, you got the dollar sign.
Oh, sorry. So at an interest of, let's say, 7.4%. It grew to, let's say, $17,000. I don't even know if this is possible, but we'll figure things out. $17,000. And it is compounded continuously. Whatever, right? So, does somebody remember what the formula for continuously was?
PRT.
Very good. P-E-R-T. That was it. PERT. Yes. So, how much money do we end up with? 17,000 equals 1,500. Do we know? Well, E stays, right? Sorry. So the E stays there. And of course, the question is how many years? What do we do for the percent? Points?
0.074.
0.074 times T. So this one's a little bit easier because we don't have so many numbers and there's only two steps. One is
Divide by 15.
divide by 1,500. And I don't even know if that's even a pretty number or not, but let's figure it
34
out.
over 3.
Okay, and that's fine. So it is 34 over 3 equals E.074t. And the only thing left for me to do is put what on both sides?
ln.
So we have ln of this, 34 over 3, equals ln of E.074t. But here they what? Cancel. So I end up with ln of 34 over 3 equals to 0.074t. And what do we do on both sides?
Divide by 0.074.
And then that right there should give you your answer. I don't know if it'll be a legit answer because I just made up this problem. So we have the fraction, we have ln, 34 divided by 3 divided by 0.74. It would take 32 years and 32.8. So t equals 32.81. This question is going to round to 2 decimal places. And
These guys are screwed.
so this one is problem 15. A was problem 16. The only thing I didn't do an example for was 14. More than likely I'll do it with you, because I'm already tired. Sounds good?
We're good.
So she didn't.
14, I'll work it out with you next time I see you.
Yay.
So, are we good?
Yes.